Hello, so in today's class we will look at second partial test and then we will see how to find the relative maxima and relative minimum function of two variables. അപ്പോൾ നമ്മൾ single variable function case we have seen the first derivative test and the second derivative test. So similar way here you have the second partial test. So the second partial test states that so if f is a function of two variables with continuous second order partial derivatives in some disk centered at the critical point x0 y0 and we'll define d equal to fxx into fyy minus fxy square which is evaluated at the point x0 y0. Then the second partial test states that so if d is greater than 0, അപ്പം ഇത് നമ്മൾ d x0 y0 ലാണ് evaluate ചെയ്യുന്നത്. So if d is positive and fxx is positive at the point x0 y0, then the point x0 y0 will be a relative minimum in that case. And if d is positive and fxx is negative, then the function has a relative maximum at the point x0 y0. Ini d less than 0 ആണെങ്കിൽ that will be a saddle point, and if d is equal to 0, then in such a case no conclusion can be drawn. So that is the second partial test. So നമ്മൾ പ്രോബ്ലം ചെയ്യുമ്പോൾ ആദ്യം first partial derivatives കണ്ടുപിടിക്കുക. So take fx equal to 0 and fy equal to 0. So the points where fx and fy equal to 0, they are called the critical points. For identifying whether a critical point is maximum, minimum or saddle point, we use the second partial test. So let us see a few examples of finding the relative extrema. So the first problem is locate the relative extrema and saddle points of so we are given the function f of xy equal to 3x square minus 2xy plus y square minus 8y. So when you find fx will be 6x minus 2y and fy is going to be minus 2x plus 2y minus 8. So when you take fx equal to 0 and fy equal to 0, we get the equation 6 minus 2y equal to 0 and minus 2x plus 2y equal to 8. So upon adding the equation, 2y will cancel off. So you will get 4x equal to 8. So that implies x is equal to 2. So when x is equal to 2, so you will get 2y equal to 6 into 2. So that implies y equal to 6. Therefore, this is a system of linear equation. It will have a unique solution. So therefore, the only critical point is the point 2, 6. Now let us find out fxx. So fxx will be 6, fxy will be minus 2 and fyy will be equal to 2. So d will be fxx into fyy minus fxy square. ഇനി എല്ലാം കോൺസ്റ്റന്റ് ആണ്, അപ്പോൾ പോയിന്റിലും സെയിം വാല്യൂസ് തന്നെ ആയിരിക്കും. So you will get 12 minus 4, so which is equal to 8 greater than 0, and again fxx at 2, 6 will be equal to 6 which is greater than 0. So therefore 2, 6 is a relative minimum. So therefore d is greater than 0 and fxx is also greater than 0. നമ്മുടെ critical point എന്ന് പറയുന്നത് relative minimum ആണ്. So next is to find the relative extrema and saddle points if any of the function f of xy equal to 4xy minus x raised to 4 minus y raised to 4. So we'll start with fx. So fx will be 4y minus 4x cube varum. Fy will be 4x minus 4y cube. So fx equal to 0 and fy equal to 0 gives, so you have y equal to x cube and x equal to y cube. You will get these two equations. ഇനി ഏതെങ്കിലും ഒരു equation method substitute ചെയ്യുക. So you will get y equal to, so y will be equal to y cube whole cube varum. So that implies, so y raised to 9 minus y is equal to 0. So do not cancel out y because that is going to give us a 0. So that is y into y raised to 8 minus 1. So you will get y into y raised to 4 minus 1 into y raised to 4 plus 1. So the roots will be y equal to 0. ഇനി ഇത് രണ്ടും നമുക്ക് real roots കിട്ടില്ല. So find out the real roots only. So y will be 0, 1 and minus 1. Now x will be equal to y cube. So and so you have x equal to y cube. So we have y equal to 0, 1 and minus 1. So therefore critical points are, so when y is 0, x will be 0. So you'll get 0, 0. Then 1 വരുമ്പോൾ രണ്ടും 1 ആയിരിക്കും. Then you will have minus 1, minus 1. So these are the critical points. Now let us find out the second order partial derivatives. So fxx will be minus 12 x square varum. Fxy is 4 and fyy will be minus 12 y square. So here d will be, so you'll get 144 x square y square minus 16. So let us find d of 0, 0. So d of 0, 0 will be minus 16. So therefore 0, 0 is a saddle point. So if d is negative, so you will get a saddle point in that case. D of 1, 1 will be 144 minus 16. So this is going to be positive, and fxx of 1, 1 will be minus 12. It is less than 0. So therefore 1, 1 is relative. fxx negative ആണ്. So 1, 1 will be a relative maximum, and d of 1 minus 1 എടുക്കുമ്പോൾ that is again equal to 144 minus 16. So that is greater than 0. And fxx of minus 1 will be equal to minus 12, again less than 0. So therefore minus 1 is a relative maximum. So therefore that is the behavior of the points. So 1, 1 and minus 1 are relative maxima, and 0, 0 is a saddle point. So next we need to find the relative extrema and saddle points of f of xy equal to x square plus y square plus 32 by xy. So we have fx equal to 2x minus 32 by x square y, and fy will be 2y minus 32 by xy square. So fx equal to 0 implies, so we will get 2 x cube y minus 32 equal to 0. So that is x cube y equal to 16. Then fy equal to 0 gives xy cube, okay, 2 xy cube minus 32 equal to 0 varum. So that gives xy cube equal to 16. So we have the equation. അപ്പോൾ ഒരു equation മറ്റൊന്നിൽ substitute ചെയ്യുക. So from here you have y equal to 16 by x cube. So you will get x into 16 by x cube whole cube will be equal to 16. So that will give x into 16 cube by x into 16 cube equal to 16. X raised to 9. So 16 cancel out. So you will get x raised to 9 minus 256 x equal to 0. Now x is common, so you will get x into x raised to 8 minus 256 equal to 0. So that implies x into, so this is 2 raised to 8, we will get x raised to 4 plus 2 raised to 4 into x raised to 4 minus 2 raised to 4 equal to 0. So that will again give x into x raised to 4 plus 2 raised to 4. ഇതിനെ നമുക്ക് x square plus 2 square into x square minus 2 square equal to 0 എന്ന് എഴുതാൻ പറ്റും. So therefore real roots are x equal to 0, 2 and minus 2. And now we have y equal to 16 by x cube. So y is 16 by x cube. So therefore at 0 y will not be defined. So therefore critical points will be so 2 x 2, then 16 by 2 cube, that will be again 2, and then 2 and minus 2 and minus 2. So these will be the two critical points. So these are our critical points. ഇനി നമ്മൾ fx ഉം fy എടുക്കുമ്പോൾ fx and fy are not defined at 0, 0. So therefore the critical points will be 2, 2, then minus 2, 2 and 0, 0. So this comes from fx and fy are not defined at the critical points. So these are all the critical points. And now let us find out the second order partial derivatives. So second order partial derivatives എടുക്കുമ്പോൾ so fx is, so we have 2x minus 32 by x square y. So fxx will be 2 minus 32 by y, again minus 2 by x cube varum. So that will be 2 plus 64 by x cube y, and again fy is 2y minus 32 by xy square. So fyy will be 2 plus 64 y cube x varum, and fxy is okay 32 by x square y square. So these are the partial derivatives. So d will be equal to, so d is 2 plus 64 by x cube y into 2 plus 64 by xy cube minus 32 by x square y square whole square. Now d of 0, 0 is not defined. So we cannot. So at 0, 0 your function is also not defined. So therefore